Hello everyone, you're joining with All in Maths. Today you're going to learn the prime numbers, factors, prime factors and the highest common factor, definitions and the usages. Join with me. So let us learn about factors first of all. What are these factors? Yes. So if I take 12, just as an example, right? If I take 12, if a question asks what are the factors of 12, basically, if you pay attention to the definition, the factors are the numbers that divide the given number without remainders. Factors are the numbers that divide the given number without any remainder. Okay, 12 I can divide by 1 without any remainder. Am I correct? Yes. Can I divide 12 by 2 without any remainder? Yes. Can I divide 12 by 3 without any remainder? Have the equal sign in the same line. Yes. 12 divided by 4 without any remainder. Yes. 12 divided by 6 without any remainder. Yes. 12 divided by 12 without any remainder. Yes. So all these numbers that divide the given number, the original number, without any remainder are called the factors. So these are the factors. Can you see the board? Okay, I'll write here. These are the factors of 12, right? Factors of 12. What are the factors of 12? 1, 2, 3, 4, 6, 12. But there's an easy way of getting this because you don't want to repeat the same process, right? So we can have these factors in an easy way. Let's see how to get it. Okay, let's see how to get it. Okay, right. I'll first erase this one. Okay, let's see how to get this factors of 12 easily, right? So, I write 12, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, right? So 4 times 3, once again the same thing. 6 times 2, once again the same thing. 12 times 1, once again. So because we don't want to write again and again the same thing. So 1 into 12 is 12 into 1. Okay. Therefore I am not rewriting that. So I can write 1 into 12, 2 into 6 and 3 into 4. So then all these are factors. So I can write in the ascending order. 1, 2, 3, 4, 6, 12. These are the factors of 12. Can you understand? Okay, what is basically a factor? Alright, another example. I'll take 24. Okay, 24. I want to see the factors or to write the factors of 24. Okay, what's the method? Some say whether 1 times goes with 24 or not. Yes. 2 times? Yes. 3 times? 8. Yes. 4 times? 6. Yes. 5 times? Doesn't go. 6 times? 4 once again. 8 times? 3. 12 times? 2. 24 times? 1. So, if I take 24, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. This is the set of the factors of 24. So what is basically a factor now? A number or the numbers that will divide the original number without any remainder. Is that clear to you? Another question which is related to sets. The circle A indicates the factors of 30. Circle B indicates the factors of 9, right? So to fill this Venn diagram, you should know what are the factors of 30 and what are the factors of 9. Okay, if I take the 30, the number 30, right here, 30. 1 into 30, yes. 2 into 15, 3 into 10, 4 into, no, 5 into 6. Then 6 into 5. Once again, we don't want to write. 10 into 3, we don't want to write because it's already written. Right, so then the factors of 30 would be these ones. 1, 2, 3, 5, 6, 10, 5, again 15, 30. Right? Okay, this is the factors of 30. The factors of 9. Factors of 9. Yes, factors of 9. 1 into 9. Then 3 into 3. Anything else? No? Okay. So then what are the factors of 9? 1, 3, 9. So then factors of 9 would be 1, 3, 9. So what are the common factors? What are the common factors which is coming in the middle of the circle in the intersection? The common factors. Yes? 3 is common. Anything else is common? Yes? 1 is also common because both are divisible by 1. Yes, then inside B you get 9. Because inside B circle altogether you have to have 1, 3, 9. 1 and 3 is already gone to the intersection. 9 is remaining. So, the one which is not coming to the intersection is outside the intersection. Coming to circle A. So, coming to circle A, now 1 is gone and 3 is gone. What are the other numbers remaining? Yes, 2, 5, 6, 10, 15 and 30. You write 2 and 5 separately, otherwise it is visible as 25. Alright, now this is the filling, the completed Venn diagram after filling. Okay, so hope you understood how to answer the questions related to factors, and already you know what are prime numbers as well. So factors, primes or prime numbers. What are prime numbers? Yes, there are two definitions. One is a prime numbers, the numbers that have only two factors. What is the first definition? The prime numbers are the numbers that have only two factors, right? If I take number 13, 13 can be divided by 1, 13 can be divided by 13 without any remainders. When you divide this, the answer is a whole number. When you divide like this, 13 by 13, the answer is a whole number, it's 1. So, if a number can be divided only by two numbers, that means 1 and itself, it's a prime number. Okay? So, the prime numbers have two factors. The numbers that have only two factors. The numbers that have only two factors are prime numbers. The numbers that have only two factors are prime numbers. So if I take 2, 2 has two factors. 2 divided by 1 is 2, 2 divided by 2 is 1. So 2 can be divided by 1 and itself. So 3. 3 has two factors, 1 and 3. Then 5. 5 has two factors. 4? No. 4 has three factors. 1, 2, 4. 4 can be divided by 1. 4 can be divided by 2. 4 can be divided by 4 without remainders. Without remainders. So 4 is not a prime. Not a prime. Okay. But 5 is a prime because 5 can be divided by 1 and 5. How about 6? 6 has three factors once again. 1 and 2 and 3 and 6. 4 factors are there. 6 can be divided by 1 without any remainder. 6 can be divided by 2 without any remainder. 6 can be divided by 3 as well as 6 without any remainder. So there are 4 factors in 6. So 6 is not at all a prime number. 7 can be divided by 1. 7 can be divided by 7. So it has two factors only. 8, no. 9 can be divided by 3 as well. So it's not a prime number. How about 10? 10 can be divided by 1. 10 can be divided by 2. 10 can be divided by 5. 10 can be divided by 10. So it's not a prime number. 11 can be divided by 1. 11 can be divided by 11. In the same way, 13, 14 no, 15 no, 16 no, 17, 19, and so on. So basically, the prime numbers have only two factors. Prime numbers can be divided by only by 1 and itself. Prime numbers, these are the main points that you have to remember about the prime numbers. The prime numbers can be divided only by 1 and itself without remainders. This is important. If we take remainders or if we take as decimals, any number can be a factor, right? We can't take decimal figures. Like let's say 13 divided by 2 is 6.5. So it can be divided. It's not that we cannot divide. But without remainders is the most important thing. The prime numbers can be divided by 1 and itself, only by 1 and itself, without any remainders. Is that clear to you? So what are the main two things that we have to remember about the prime numbers? The prime numbers have only two factors and the prime numbers are divisible by 1 and itself. Very good. Okay, now we will look into some prime number questions. Okay, if a question asks you, what are the 7th and 8th prime numbers? How would you answer? Yes, 7th and 8th. So you should know what is a prime number. What's a prime number? Yes, what's a prime number? A number that can be divided by 1 and itself. So what is the other definition? Prime numbers have only 2 factors. Alright. Now 7th and 8th prime numbers I have to give. So 7th and 8th prime numbers, if I want to give them the 7th and 8th prime numbers, I should know the prime numbers up to a certain extent, right? So basically, you have to remember the first prime number is 2, then 3, 5, 7, 11, 13, 17, 19, then what? 20, no, 21, no, 23, 23, 24, no, 24 is divisible, 25 is divisible, 26 is divisible, 27 is divisible, 29, yes, 30, no, 31, yes, so on. So you can see 1, 2, 3, 4, 5, 6, 7th prime number is 17 and the 8th prime number is 19. Okay, so our answers are 17 and 19, right? So these are the 7th and 8th prime numbers. So in some sets questions also, Venn diagram questions also, they might ask, they can give inside the Venn diagram, they can give here even numbers, here prime numbers. Okay, this is even, these are primes. So they might give the numbers, the universal set is the numbers below 50. So you should include all the even numbers below 50 in the even number circle and the prime numbers below 50 in the prime number circle. What is the intersection? What is the only even prime number, as you know? Only even prime number. Yes? It is 2. All the other prime numbers are odd, right? Only even prime number is 2. So 2 comes over here. So likewise, you will get different questions related to prime numbers. So hope you understood prime numbers. Let us move on to the prime factors. We'll see what are prime factors now. Okay. Now you have learned the factors. You have learned the prime numbers also. And then now you are going to learn the prime factors. So if I take any number, let's say 35, and I want to write the factors of these factors, 1 into 35 and 5 into 7. Other than that, we don't have any other factors. So what are the factors of 35? These are the 4 factors of 35. Out of these factors, the numbers which are prime numbers, the factors which are primes, are called the prime factors. Okay, is 5 a prime number? Yes. Is 1 a prime number? No. Is 7 a prime number? Yes. So it's a prime factor. So 5 and 7 are prime factors of 35. Okay, 5 and 7 are prime factors of 35. If I take another example, okay, let's see another example. Right, you can see the board, right? Right. Okay, I'll take 28. 1 into 28, yes. 2 into 14. I'm writing the factors first, right? First I'm writing the factors and then we are trying to recognize the prime factors. So, is 28 divisible by 3? Is 28 divisible by 3? No. 4 times? 7? 6 times? Or 5 times? No. 7 times? Yes. 7 times 4. Then again it comes to 14 times 2, like that. So then what are the factors? 1, 2, 4, 7, 14, 28. 1, 2, 4, 7, 14. Now, you're going to learn the highest common factor. Now you have learned the factors, you have learned the prime factors also. Now you are going to learn the highest common factor. Alright, the highest common factor. 12 and 24. I want the highest common factor of 12 and 24. So, usually what the students do when they get a question like this is, they divide 12, divide by 2, 6, divide by 2, 3, divide by 3, 1. So they write 12's factors are 2 into 2 into 3, right? And then again, they take 24, okay? They take 24. Now this is 12. 24 also they take. They divide by 2, 12, 2, 6, 2, 3, 3, 1. So they divide and go, right? So they write 2 into 2 into 2 into 3. So as they write 24 is equal 2 into 2 into 2 into 3. 2 and 2, 2 and 2, they tell that this is associated, this is like that. And then 2, one time they take, because here 2 and 2 are common. Because of that, they write 2. You can't see, I guess. Hope this will be clear. Okay. So 12 and 24 factors you can see. So I'll adjust a little more. Okay. Alright. Okay. So now I want to write the highest common factor of 24. So what usually they do is they're selecting one of them 2. One of them times 2. One of them times 3. 2 times 2, 4. 4 times 3, 12. So they write the highest common factor of 12 and 24 is 12. It's fine, it's correct. It's not wrong. But there's an easy way to do this. You don't want to take 12 separately and divide and go. Again 24 separately, divide and go. So you don't want to do that. If you get a number like 108, then you will have so many steps. If you get 220, you will have so many steps. So better if you divide this one at once. Okay? So let us divide at once and take in the short form. We'll see how we can do that. Alright, now I want the highest common factor of 12 and 24. And I'm going to use the short method. Okay? 12, 24 we write together. What do I need now? The highest common factor of 12 and 24. Okay. So now I'm dividing this by 2. First I divide by 2. So it comes here 6 and 12. Then again divided by 2. 2 times 3, 2 times 6. I can divide by 3. 1 and 2. We have to remember one thing. For the LCM, for the lowest common multiple also we divide and go. Although I can divide both the numbers or one number, I have the freedom to take any prime number to this side and divide. Okay? But in the highest common factor, we don't have that privilege. In the highest common factor, we can divide the two numbers only by the prime numbers that I can divide both. That is the condition. Right? What's the condition? I have to select the numbers here. When I'm selecting the numbers or prime numbers here to divide, I have to select only the numbers that will divide both the numbers. Both the numbers. That's the condition. Okay? Alright. Now, I have 2 and 2 and 3. See? 2, 2, 3. 2 times 2, 4. 4 times 3, 12. And 12 is the highest common factor of 12 and 24. So easy. You don't want to take 12 and divide till the end. You don't want to take 24 and divide till the end. And then rewrite the factors and then draw in sausages or whatever the shape that you are drawing there. and then selecting the numbers and writing and calculating. So it's a long unnecessary step. So here you have an easy step to get the HCF. What is the condition here? Can I just select any number that will divide any number? No. You have to select only the prime numbers that you can divide both the numbers at once. That's the condition. If you come to a place where you cannot get such a number, such a factor, stop there, get the left side and calculate and write. I'll give another example. This is the next question, next example. So I have 51 and 102. I want the highest common factor of these two numbers. So what is the easiest way? Write both the numbers. Okay, I wrote 51, 102. The easiest way, right? Okay. So what is the first number that we can select? Yes, it's divisible by 3. 3 times 17 is 51. 3 times 17. So if I take 102, yes, if I take 102, if in 10 how many 3s? 3. In 12 how many? 4. 34. So then I can divide this by 17 also. 17 divided by 17, 1. 34 divided by 17, 2. I selected 3 because I can divide both the numbers. I selected 17 because I can divide both the numbers. But I cannot select another prime number which I can divide both the numbers without any limit. Therefore, I stop here, select my left side and get the product. Simple as that. 3 times 17 is 51. So 51 is the highest common factor of these two numbers. Is that clear to you? Hope it is very clear. Today you learned the prime numbers, factors, prime factors and the highest common factors. Hope you understood. If you have confusions, if you want more explanation, you can put a comment in the comment box so that I can give out the answers for such questions in the next video. Have a great day.